Assalamualaikum warahmatullahi wabarakatuh. I'm Ahmad Irfan bin Azhan and I'm going to explain Lab 2, question 2. So as you can see here, we have the R value which we set to unknown, which is in the word type. And then we have the X value which we set to 26 in the word type. And then we have Y value we set to 30 in the word type. And lastly, we have the Z value which set to 40 in the word type. So we're going to run the program now. So first, we're going to move the X value, which is 26, to the EAX. So from this value, EAX, we will change to 26 also, as you can see here. And then we're going to negate the EAX value, the 26, to the negative value, which is negative 26, as you can see here. And next, we're going to move the Y value into EBX, which is 30 into EBX. So this value will change to 30 also, as you can see here. This has to change. And then we're going to subtract the Z value from EBX, which is 40 subtract by 30. 30 subtract by 40. So it will become negative 10. As you can see here, this is negative 10 in this the type. And then we're going to add the EBX negative 10 to EAX, which is negative 26, which is going to be negative 36 minus negative 10, which is going to become negative 56. It become as you can see here. And then we're going to increment EAX, so we're going to add 8 by 1. So this value, you will see, it will add 1. As you can see here, 1 is added. And lastly, we're going to store this value into the R value. As you can see here, the R value is also the same as the EAX. So that's it for question 2. I'm going to explain the Lab 2 question 4. So first we have the value 1. We set it to 40 in word. And then we have variable 2. We set it to 10 in word. And then we have variable 4, which is unknown, but we ready the number of bits with word. Now we're going to run the code. So first, we're going to move the variable 1, which is 40, to AX. As you can see here, the AX is this value for now. And then after we run this line, it's going to change to 40 also. As you can see here, it's changed. And then we're going to move this value 5 into BX, which BX now is this value, but then it will change to 5 when we run the line. As you can see here, it's also 5. And then we're going to multiply AX, which is 40, with BX, which is 5. So, and then the product of that value, we're going to save to AX, which is 200. As you can see here. And then we're going to move the variable 2, which is 10, to BX. As you can see here, BX is 5 for now. And then after we run the line, it changed to 10. And then we're going to subtract this value, BX value, with 3. So the value will change to 7, as you can see here. And then we're going to divide the AX value, which is 200, with the BX value, which is 7. So 207. And then we're going to change, we're going to store that product value, which is 28, in the AX. As you can see here, the AX is 28 because we divided 200 with 7, which we got 28. And then lastly, we're gonna move the value of AX 28 into the variable 4. So as you can see, variable 4 has no value, but then we're gonna store it with 28. So that's it for question 4, Lab 2. Then Lab 2, question 6. So first I'm gonna set the quotient value, which is say this. We set to unknown, and then the word type is a word. Then we're gonna set the remainder, which is in word, for we're ready for the number of bits, and the value is unknown. Now I'm gonna run the program. So first, we're gonna clear the dx value with 0. So how to clear it? We set the dx to 0. As you can see here, this is the default value. Now we're gonna clear it by changing this to 0. As you can see here, the dx now is 0. And then we're gonna load the AX with 803 hexadecimal. As you can see here, 2051. And then we're gonna load the BL with 10 hexadecimal. So the base now this, and then after below it with 10 hexadecimal, the value is now this. And then we're going to divide ax with bl, and the result will be stored in ax. As you can see here, this is the product of the division, and then we're going to call them rect, so it will show the registers, as you can see here. The ax is this value, and the ax is this value. And now we're gonna store the ax to the quotient, because the quotient is the result of the division, which is 896. We're gonna store it in the quotient. As you can see here, now the quotient is 896. And now we're gonna store the remainder, which is currently defaultly stored into dx. So we're gonna store the value of dx into the remainder, which is 0. So not change. That's it. Thank you.